This is a quick review of how to add and subtract mixed numbers with unlike denominators. So the core strategy for this is just the same as with regular fractions. Find an equivalent fraction that makes both denominators have the same value. But there's an additional strategy we need to know. If this was our first problem, many students have an instinct left over from multiplying fractions and dividing fractions. When multiplying and dividing fractions, you should convert to a fraction greater than 1 if you have a mixed number. But when you're adding and subtracting, a core strategy is don't convert to a fraction greater than 1 because whole numbers already have equivalent denominators. 2 and 1 can already be added to one another just in the same form they are. We don't need to change their form. To really show you why this is important, I'm also going to make this the first problem. If we were to convert 26 and 1/2 to a fraction greater than 1, we would end up with a much larger numerator because we'd have to do 26 times 2 and get 52 plus 1 is 53 in the numerator here. And on this side, we'd have to do 12 times 4 and get 48. 48 plus 3, and we get 51 in the numerator over here. And that's even before we tried to find an equivalent fraction. So not only do we need to find an equivalent fraction to make both denominators equivalent, we need to don't convert to a fraction greater than 1. Okay, now as we do this, we're going to use some strategies that we are already familiar with. We're going to set this up as though this is a whole number addition problem. The reason why this is important is because it will help us see that the fractions occupy one zone, sort of one place value. Then we have ones, then we have tens. Okay, now what we need to do is we need to find an equivalent for this one. So I could come over here and I could draw 1/2, and we need to make that into fourths. Okay, if I go like that, okay, all of a sudden we got 2/4. Another strategy would be simply to say, okay, 1/2, how do I get that to fourths? Okay, 2 times 2 is 4, so I need to do the top as well, so 2/4. Okay, now what I'm going to do is I'm going to rewrite this problem because I wrote it in pen. I should have written it in pencil. 26 and 2/4 plus 12 and 3/4. Now that we have a common denominator, we can add 2/4 plus 3/4 is 5/4, and then 2 plus 6 is 8, and then 2 plus 1 is 3. Many students will stop here, but notice that we have a fraction greater than 1 inside the mixed number. That is not something that can stand. We must take out a whole and put it into the ones place. 5/4, there is one whole inside that. If I take out 4/4, there's 1/4 left over. So this is equivalent to 39 and 1/4. The same strategy works when we are subtracting. So here is our next problem. 37 and 3/8 minus 22 and 3/4. All right, looking at this, I have different denominators. I think I need to change the fourths to get it equivalent to the eighths. So over here, I could draw 3/4. 1, 2, 3. If I split it one time, one part is now equal 1 out of eighths, or 1 out of 8. So that means I have 1, 2, 3, 4, 5, 6 eighths. My other strategy is I could have started with 3/4 and said, okay, if I multiply 4 times 2, that gets me 8. I multiply 3 times 2, that gives me 6. Okay, so 6 eighths. Now I'm going to set up my problem using my new equivalent fraction. I'm going to, again, set it out vertically, just like I would a regular whole number subtraction problem. And we should look carefully and notice an issue. We can't do 3/8 minus 6/8. 3/8 is too small. Well, how would you handle that in a normal addition problem? In a normal addition problem, you would regroup. Let's imagine for a second that this was 373 minus 226. Same thing, we can't do 3 minus 6. So what you would do is cross out the 7, and you would decompose 7 tens and take away one of those tens so that there's now 6 tens, and then decompose this one of those tens into 10 ones. You would add 10 ones to the ones place. 3 plus 10 is 13. And again, it's not that we're just putting a 1 right here. It's that we're doing 10 ones plus 3 ones equals 13 ones. Many students will make a mistake over here because they'll just put a 1 next to the 3. But we're not going to be adding 10 ones this time. That's because we're not adding a whole number. We're adding eighths. Okay? In eighths, 8 eighths equals 1 whole. So when I cross this out and write a 6, what I'm transferring over here is not just 10, I'm adding 8/8. So 8 plus 3 is 11/8. Now I can do 11/8 minus 6. 11/8 minus 6 is 5/8. 6 minus 2 is 4. 3 minus 2 is 1. So my answer is 14/5/8. Okay, I want to show you one more example before I send you to some practice. 59 1/2 minus 46 7/10. I'm not going to be able to multiply 10 to get 2, but I can multiply 2 up to get 10. Let's say 1/2 times what? Times 3? No, times 4. 1/2, 2 times 5. Oh, that's going to get me 10. Whatever I do to the denominator, I must do to the numerator. So that means that 1/2 is equivalent to 5/10. Likewise, I could have drawn a picture model, but I would have had to recognize that I can't just split it one time. I'm going to have to split this into 5 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Now it's 5/10. Let's set up my problem vertically. 59 5/10 minus 46 7/10. Okay, we can't do 5 minus 7. We're going to have to decompose from a place of higher value. So I'm going to cross out 9. I'm going to remove one of those ones, and I'm going to have 8 left. Now I need to add an equivalent value of 1 over to this. So in my last problem, we were using eighths. So 8/8 is 1. In this problem, we're using tenths. How many tenths are 1? Well, 10/10 equals 1. Therefore, in this case, I do get to say 10 plus 5 equals 15. Okay? So now I can do 15 minus 7. That's going to give me 8/10. 8 minus 6 is 4, 8 minus 6 is 2, and then 5 minus 4 is 1. I can simplify this by dividing by a factor of 2 that they both share. So we're going to get 12 4/5 for the final answer. Okay, so strategies to keep in mind. Just like normal, find an equivalent fraction that makes both denominators have the same value. But when you're dealing with mixed numbers, don't convert to a fraction greater than 1. Keep it a mixed number because whole numbers already have equivalent denominators. Finally, when you set it up vertically like a whole number addition or subtraction problem. That will prepare you for regrouping much more efficiently. Here's 3 problems to practice. Go ahead and pause the video to try them, then I'll reveal the answers. All right, I'm going to reveal the answers. Check yourself, find any mistakes that you've got, and then move on to more practice.